Let's take a quick journey of a genius who had a humble beginning but leaving us a beautiful legacy, and who is also considered as the most romantic figure in the recent history of mathematics, Srinivasa Ramanujan.
The 18th century German philosopher Arthur Schopenhauer said, "Talent hits a target no one else can hit. Genius hits a target no one else can see." This ability to see a solution that no one else dreamed of is what ultimately defines a genius. Not to merely have an original idea, but a perspective that profoundly changes our understanding and causes us to question what we know or what we think we knew. A friend of mine who's a mathematician actually offers this. He said to me, "A mathematical genius is someone who can prove the unimaginable." So we're going to talk about math genius.
People should do what they do well. Like, leave them alone to do what you're good at. And in his case, he was, except for Euler, probably the greatest discoverer of formulas ever. I think those are the two. And in the history of math, nobody liked them for visionaries.
Srinivasa Ramanujan was born to Komalathammal and Kuppuswamy Srinivasa in Erode district, Tamil Nadu, the then Madras Presidency, on December 22, 1887. Later in a year, they moved to Kumbakonam. His lifetime of 32 years could be viewed as quadrants. The first phase is his connections in Kumbakonam. He spent slightly more than 50% of his lifetime, that is about 17 years, in Kumbakonam, where his innate ability to solve problems by himself arose. Two books which sparked the curiosity and awakened his genius during his school days were A Synopsis of Elementary Results in Pure Mathematics by G.S. Carr and Orders of Infinity by G.H. Hardy. The range of problems he was solving included quartic, quintic, infinite series, Bernoulli's numbers, calculating Euler's constant, solving hypergeometric series, fractions, divergence series, just to name a few. He had the habit of recording all his findings, theorems, equations, solutions in loose sheets and or notebooks. These notebooks later became the popular Ramanujan's notebook. Then his second part was in Madras, where again he spent considerable years, say about 8 years, during which he got married to Janaki Amman, joined as a clerk in Madras Port Trust. This is where he got few influential friends who motivated Ramanujan to contact renowned mathematicians. As Arthur Conan Doyle says, only talent instantly recognizes genius. G.H. Hardy identified and understood Ramanujan's intelligent work. This was a game changer for Ramanujan to enter into a collaborative work with Hardy at Trinity College, Cambridge, where he stayed for about 5 years. The rest is history. And Ramanujan returned back to India in 1919, but even with his ill health at Chennai, he was unstintingly working on Q series, Mach theta function, modular equations and relations, integrals, Dirichlet series, congruences, but which he communicated to Hardy in his last letter. All of his work, which he carried out on his return, were in 87 loose and unordered sheets, which now staged in his last notebook. His health condition deteriorated further and he passed away on April 26th. Many globally renowned mathematicians were or still struck with awe about the geniusness of him, and some of them are still endeavoring to understand and solve Ramanujan's theorems.
He was mathematically gifted as a child. When he went to high school, you can visit the high school in Kumbakonam and you will see certificates that he won because of his mathematical skill. Mathematics really took hold of him. He was sufficiently talented.
Ramanujan is a complete singularity, is most unusual, absolutely unique in the world. He's someone who learned mathematics essentially all by himself. Every great mathematician went through a good course of studies, and most of them had very good teachers, at least people who inspired them, taught them what to learn. Not Ramanujan. He learned all by himself, fearlessly attacked the big problems in number theory, the problems that nobody could do at the time and anywhere in the world. And he thought that he could just go and solve them. The mathematical scene in England in the first half of the 20th century was dominated by two mathematicians, G.H. Hardy and Littlewood, J.E. Littlewood.
Was a role model for me, and like all role models, there's a lot that we can learn from them. And in Ramanujan, I learned that I learned that I could be quite happy by pursuing mathematics for its own, for its own beauty. It wasn't about great grades or perfect test scores. It was really about the passion of unraveling mathematical mysteries.
He started basically from zero. He didn't have a formal education the way other mathematicians did. He started from the beginning and made his own path to the theorems that he was coming up with.
I first heard of Ramanujan almost 60 years ago from Paul Erdős, a great Hungarian mathematician, who passed on to me Hardy's remarks about natural talent. I mean, both Erdős and Hardy thought that Ramanujan was the most talented mathematician ever in the world, as far as natural talent, pure talent is concerned, whatever that means. So Hardy liked to construct lists and liked to rate events and cricketers and people and everything. So he also rated natural talent in mathematicians, and in that, on the scale of 0 to 100, he gave himself 25, he gave Littlewood 30, David Hilbert, who is the greatest mathematician of the 20th century, 80, and Ramanujan 100. But the pure talent is not quite the same as knowing mathematics and being able to prove things.
Being played is called the tabla, which is an instrument that was played that's played in the temples in South India. It's a South Indian percussion instrument, and actually, it's very relevant to Ramanujan's story because Ramanujan did a lot of his work sitting in his temple, his hometown temple lobby. And he would sit there, and this is the music. This is the kind of music that was played. The tabla is the South Indian temple drum. And so this is the kind of background that he had when he was writing down some of his extremely creative formulas, some of which made their way into the letter that he sent to Hardy later on. The other connection of art with Ramanujan is that his mother was a Carnatic classical singer. So in this genre, she was a vocalist. And so Ramanujan really grew up with music in his home. All these rhythms that he was hearing, his mother singing these classical tunes that are, again, the frequencies that are chosen in Carnatic music are based on very mathematical ideas. And so all these things, these creative aspects of mathematics were somehow in the background, even though they weren't explicitly so in a school system.
Is in these notebooks that Ramanujan wrote at the time that he was at the time and before when he was working at the Madras Port Trust. Many of his friends encouraged him to write to some English mathematicians in order to gain favor of and help from them. And he actually wrote to 3 mathematicians. The first 2 rather brushed him off. And fortunately for Ramanujan, however, the third person he wrote to was the person I just quoted, G.H. Hardy. He wrote as follows: "Dear Sir, I beg to introduce myself to you as a clerk in the accounts department of the Port Trust office at Madras on a salary of only £20 a year. I am now about 23 years of age. I've had no university education, but I've undergone the ordinary school course. After leaving school, I've been employing the spare time at my disposal to work at mathematics. I've not trodden through the conventional regular course, which is followed in a university course, but I am striking out a new path for myself. I have made a special investigation of divergent series in general, and the results I get are termed by the local mathematicians as startling. I would request you to go through the enclosed papers. Being poor, if you are convinced that there's anything of value, I would like to have my theorems published. I have not given the actual investigations nor the expressions that I get, but I have indicated the lines upon which I proceed. Being inexperienced, I would very highly value any advice you give me. Requesting to be excused for the trouble I give you, I remain, dear sir, yours truly, S. Ramanujan." And with this letter, he sent along a number of formulas, and in amongst them were these 2 formulas. There were also a variety of assertions, some definite integrals, a real varied collection of mathematical results. Fortunately, I think in these formulas one finds some definite integrals that Hardy himself had actually been working on and had been sufficiently proud of them that he published this, so that when seeing these same integrals in Ramanujan's letter, Hardy immediately realized that here was a mathematician of exquisite taste. In addition, there were formulas here which absolutely stunned Hardy, and the two you see on the screen are examples.
Hardy wrote about this, that Hardy sees these formulas, some of which he recognizes as the formulas at the cutting edge of math of his day. So he knows that this is not really a crackpot, clearly not.
But Hardy knew that the author of this letter, who turned out to be the Indian clerk Ramanujan, had to be, at some level, a natural genius. Hardy would later write about this letter the following words, and in particular about the last 3 lines of Ramanujan's letter. These formulas defeated me completely. I'd never seen anything in the least like this before, and they could only be written down by a mathematician of the highest class. And they must be true, because no one would have the imagination to invent them. These are lovely words. Ramanujan went on to write 30 papers covering an incredible cross-section of mathematics, mostly in analytic number theory, but these papers have inspired many different areas that continue to thrive to this day.
I think it was Littlewood who said, for him, the whole numbers were like personal friends. He knew things about each of them.
It was Littlewood who said that every natural number was Ramanujan's best friend. So every natural number was Ramanujan's friend. Natural numbers are 1, 2, 3, 4. It doesn't make much sense to somebody who is not a mathematician, but as an example, people always quote this little story that when Hardy went to visit Ramanujan in Patni, where he was in a hospital, then Hardy was lost for words, as mathematicians tend to be, and didn't really know what to talk to this man who is ill. So he just mentioned that I came in a taxi, and but the number of this taxi was very dull. What was it? Asked Ramanujan. 1729. Oh, Hardy, how can you say that? 1729. It's a very interesting number. It is the smallest number that can be written as the sum of 2 cubes. So 1729 is 10 cube plus 9 cube, and also 12 cube plus 1 cube. But the fact that Ramanujan instantly said it is truly amazing. That he had this familiarity, that he loved to see what these numbers look like.
I read somewhere, I don't know if it's true, that Hardy said that Ramanujan at that time had no equal, no rival. 100 years later, would that still hold true?
It's in the fact that somebody sprang fully armed like Pallas Athena is still unique. Nobody even comes close to it. Absolutely close to it. So there is nobody about whom you could say,
the first Indian fellow at Trinity.
Having got an FRS for Ramanujan, Hardy and Littlewood again proposed Ramanujan for a Trinity fellowship.
Wrote on his deathbed to Hardy he was on his deathbed. He was extremely sick, and yet he was still producing these ridiculous formulas and sending them to Hardy. And we still have that letter today. And in that letter, he's trying to get a lot of his ideas out because he knows maybe he doesn't have that much time. And so in this letter, he writes some incredible formulas, and he describes one of the very important functions in mathematics are called theta functions. And in that letter, he introduces a concept he calls mock theta functions, which have properties like these most important theta functions, and he predicts they will be just as important in mathematics as these theta functions that had been passed on for decades and been used in every application imaginable. And people looked at this for maybe half a century, and they're like, well, it's clearly not as important as regular theta functions, that we don't even know what this means. What is he talking about?
As we all know, Hardy kept saying that association of Ramanujan is a romantic incident in his life. But I would extend it to say that even now it's happening with many, many mathematicians, but through his notebooks. The journey of Ramanujan's 3 notebooks containing 3,000 to 4,000 theorems had its own dramatic twist and turn. On the untimely demise of Ramanujan in 1920, Janaki, wife of Ramanujan, had all the transcripts to the University of Madras. University of Madras sent it to Hardy for possible publication. And these 3 notebooks kept traveling back and forth, and finally, Hardy popularized his second notebook through his 12 lectures. And then Rankin, successor of Watson, discovered majority of the materials at Watson's home, which he passed on to Trinity College, Cambridge. Bruce Berndt, an American mathematician, went on to publish Ramanujan's work in 5 volumes. George Andrews, who read Ramanujan's mock theta functions in 1976, says that the way Ramanujan conceived mathematics is still a mystery. Back in India, in 1957, Tata Institute of Fundamental Research, TIFR, Bombay, published the unabridged photocopy version of notebooks, and then during 1987, Narosa Publishing House published the greater part of his remaining unpublished work, which was earlier in the possession of G.N. Watson. To date, mathematicians around the globe are still working and using Ramanujan's theory extensively.
And it took 80 years, and there was a PhD thesis of someone named Zweigers in Germany. And he got to the bottom of what Ramanujan meant by this. And he gave an explanation of where Ramanujan was going with this. And he wrote his PhD thesis about this 80 years after this enigmatic letter that Ramanujan wrote. And now it's blossomed into a whole field called mock modular forms. And now these mock modular forms are coming up everywhere in physics, and there were some questions about black holes and string theory that had been open for so long, and we've now realized that exactly those formulas that Ramanujan wrote in this deathbed letter are what we need to understand that problem.
So string theory, black holes.
And this is cutting edge. This is just in the last year that this has happened.
Yeah, this work leads us to insights about the actual universe. That is, there's a kind of structure in the universe that is mathematical that is deeper than any creative human force. That, I guess I'm not saying it very well, but it's as if it's a very profound mystery how the universe can know math. How can it be built on math so that the things that he's seeing in his mind, or that the goddess Namagiri is giving him on his tongue, 80 years later are turning out to describe the structure of fundamental physics at the deepest level. How can that be? How can the world be built like that, if it is? I mean, we don't even know if this is correct yet, because we don't know if string theory is correct. But if it is, how spooky is it that this was anticipated on his deathbed?
And it almost wasn't seen. One takeaway would be that you have to be open as a person and allow people, to be able to recognize genius. I mean, this man came from South India at the turn of the century, and the odds that anybody ever knew his name outside of there, or even there, is astronomical.
They could probably figure out what the odds are.
They might be able to, but I think today there's a lot of other Ramanujans out there, and it takes an openness and a willingness to see genius in places that maybe you wouldn't expect it right away. So
I love that.
A couple other takeaways. I mean, one is what we were just talking about, that mathematics should also be taught that way as a creative subject, and that's hopefully a takeaway that teachers will get, and schools will get, and the educational system will get. And finally, there's a very important message that talent can be found anywhere, and we really have to make our education system good enough so that anyone can come through. If they're geniuses, we will find them, and we will be able to nurture their talents and advance their society as a result.
Is so many different things. So if art doesn't move you, there's also, math is very connected to science and to nature. It's a game. My kids find it just satisfying to get the right answer. That is, there's something very satisfying in the manner of crossword puzzle or Sudoku. There's also the social aspect. I mean, it is many, many things. Some people say math is a language. So there are many avenues into it. It's history, it's human connection, it's everything. So that's the message I would like to leave. That don't think of it as some disconnected, annoying subject that you had to do in high school. You were just mistaught if that's what you thought it was. It's really it's everything that human beings do.
One thing is absolutely clear, he worked really hard. Stories are told of even when, in his youth that he used to do all his calculations on a slate. And a slate, as you know, is not a very big writing area. And his calculations are quite complicated. So he used to scribble them, then he used to erase what was on the slate using his elbow and write it again and fill it up. So you could imagine that he could have said, look, I don't have an iPad to work on. He just had this little slate and he kept working on it. And he worked quite hard. He lived mathematics, he dreamt mathematics. And so that's the lesson number one I take, is that there is nothing to stop you from discovering really deep things. You can't blame your circumstances or your environment, but if the passion is there, if the desire is there to know something, to go deeply into something, then you can make yourself wherever you are. And at least that's what Ramanujan's story tells us. Now, granted that there is such a thing as genius, and I'm not saying that everybody who tries will be the same level of genius. Maybe they will, maybe they won't, maybe they'll be even greater. But the point is, the door is open for all of us to try, and so circumstances notwithstanding, we can still make a path for ourselves.
It's the idea that greatness and talent is often found in the most unpromising of circumstances. And it's our responsibility, if you're a parent or a professor or a teacher, it's our responsibility to first locate that talent, nurture it, and help it thrive. And certainly that's something that we see in Ramanujan. An Indian, discovered by the great G.H. Hardy, and through their collaboration, left us, the working mathematicians of today, these 3 notebooks and many papers that continue to drive research long after their time.